In mathematics, division by zero is division where the divisor is zero. Such a division can be formally expressed as a/0 where a is the dividend. In ordinary arithmetic, the expression has no meaning, as there is no number which, multiplied by zero, gives a, and so division by zero is undefined. Since any number multiplied by zero is zero, the expression 0/0 has no defined value and is called an indeterminate form. Historically, one of the earliest recorded references to the mathematical impossibility of assigning a value to a/0 is contained in George Berkeley's criticism of infinitesimal calculus in the Analyst. There are mathematical structures in which a/0 is defined for some a. However, such structures cannot satisfy every ordinary rule of arithmetic. In computing, a program error may result from an attempt to divide by zero. Depending on the programming environment and the type of number being divided by zero, it may generate positive or negative infinity by the IEEE 754 floating point standard, generate an exception, generate an error message, cause the program to terminate, or result in a special not a number value. In elementary arithmetic, when division is explained at the elementary arithmetic level, it is often considered as splitting a set of objects into equal parts. As an example, consider having 10 cookies, and these cookies are to be distributed equally to 5 people at a table. Each person would receive equals 2 cookies. Similarly, if there are 10 cookies, and only one person at the table, that person would receive equals 10 cookies. So, for dividing by zero, what is the number of cookies that each person receives when 10 cookies are evenly distributed amongst 0 people at a table? Certain words can be pinpointed in the question to highlight the problem. The problem with this question is that, when there is no way to evenly distribute 10 cookies to nobody. In mathematical jargon, a set of 10 items cannot be partitioned into 0 subsets. So, at least in elementary arithmetic, is said to be either meaningless, or undefined. Similar problems occur if one has 0 cookies and 0 people, but this time the problem is in the phrase the number. A partition is possible, but since the partition has 0 parts, vacuously every set in our partition has a given number of elements, be it 0, 2, 5, or 1000. If there are, say, 5 cookies and 2 people, the problem is unevenly distribute. In any integer partition of a 5 set into 2 parts, one of the parts of the partition will have more elements than the other. But the problem with 5 cookies and 2 people can be solved by cutting one cookie in half. The problem with 5 cookies and 0 people cannot be solved in any way that preserves the meaning of divides. Another way of looking at division by zero is that division can always be checked using multiplication. Considering the 10/0 example above, setting x equals 10/0, if x equals 10 divided by 0, then x times 0 equals 10, but there is no x that, multiplied by 0, gives 10. If instead of x equals 10 over 0 we have x equals 0 over 0, then every x satisfies the question, what number x, multiplied by 0, gives 0. Early attempts. The Brahma's Futa-Siddhanta of Brahmagupta is the earliest known text to treat 0 as a number in its own right and to define operations involving 0. The author failed, however, in his attempt to explain division by 0, his definition can be easily proven to lead to algebraic absurdities. According to Brahmagupta, a positive or negative number when divided by 0 is a fraction with the 0 as denominator. 0 divided by a negative or positive number is either 0 or is expressed as a fraction with 0 as numerator and the finite quantity as denominator. 0 divided by 0 is 0. In 830, Mahavira tried unsuccessfully to correct Brahmagupta's mistake in his book In Ganita Sara Samgraya, a number remains unchanged when divided by 0. In algebra, it is generally regarded among mathematicians that a natural way to interpret division by 0 is to first define division in terms of other arithmetic operations. Under the standard rules for arithmetic on integers, rational numbers, real numbers, and complex numbers, division by 0 is undefined. Division by 0 must be left undefined in any mathematical system that obeys the axioms of a field. The reason is that division is defined to be the inverse operation of multiplication. This means that the value of AB is the solution X of the equation BXA equals AA whenever such a value exists and is unique. Otherwise the value is left undefined. For B equals 0, the equation Bx equals A can be rewritten as 0x equals A or simply 0 equals A. Thus, in this case, the equation Bx equals A has no solution if A is not equal to 0, and has any x as a solution if A equals 0. In either case, there is no unique value, so is undefined. Conversely, in a field, the expression is always defined if B is not equal to 0. Division is the inverse of multiplication. The concept that explains division in algebra is that it is the inverse of multiplication. For example, since 2 is the value for which the unknown quantity n is true, but the expression requires a value to be found for the unknown quantity n. But any number multiplied by 0 is 0 and so there is no number that solves the equation. The expression requires a value to be found for the unknown quantity n. Again, any number multiplied by 0 is 0 and so this time every number solves the equation instead of there being a single number that can be taken as the value of 0/0. In general, a single value can't be assigned to a fraction where the denominator is 0 so the value remains undefined. 0/0 is known as indeterminate fallacies based on division by 0. It is possible to disguise a special case of division by 0 in an algebraic argument, leading to spurious proofs that 1 equals A2 such as the following, with the following assumptions. The following must be true. Dividing by 0 gives. Simplified, yields. The fallacy is the implicit assumption that dividing by 0 is a legitimate operation with the same properties as dividing by any other number. In calculus, extended real line, at first glance it seems possible to define A/0 by considering the limit of AB as B approaches 0. For any positive A, the limit from the right is. However, the limit from the left is. And so the is undefined. Furthermore, there is no obvious definition of 0/0 that can be derived from considering the limit of a ratio. The limit does not exist. Limits of the form in which both e, x, and g, x, approach 0 as x approaches 0, may equal any real or infinite value, or may not exist at all, depending on the particular functions e and g. These and other similar facts show that the expression 0/0 cannot be well defined as a limit. Formal operations. A formal calculation is one carried out using rules of arithmetic, without consideration of whether the result of the calculation is well defined. Thus, it is sometimes useful to think of A/0, where or permel A0, as being. This infinity can be either positive, negative, or unsigned, depending on context. For example, formally. As with any formal calculation, invalid results may be obtained. A logically rigorous computation would assert only that since the one-sided limits are different, the two-sided limit does not exist in the standard framework of the real numbers. Also, the fraction 1/0 is left undefined in the extended real line, therefore it and are meaningless expressions. Real projective line. The set is the real projective line, which is a one-point compactification of the real line. Here means an unsigned infinity, an infinite quantity that is neither positive nor negative. This quantity satisfies, which is necessary in this context. In this structure, can be defined for non-zero A, and it is the natural way to view the range of the tangent and cotangent functions of trigonometry. Tan x approaches the single point at infinity as x approaches either or from either direction. This definition leads to many interesting results. However, the resulting algebraic structure is not a field, and should not be expected to behave like one. For example, is undefined in the projective line. Riemann sphere. The set is the Riemann sphere, which is of major importance in complex analysis. Here too is an unsigned infinity or, as it is often called in this context, the point at infinity. This set is analogous to the real projective line, except that it is based on the field of complex numbers in the Riemann sphere, but is undefined, as is extended non-negative real number line. The negative real numbers can be discarded, and infinity introduced, leading to the set 0, AA, where division by 0 can be naturally defined as A/0 equals AA for positive ELA. While this makes division defined in more cases than usual, subtraction is instead left undefined in many cases, because there are no negative numbers. In higher mathematics, although division by 0 cannot be sensibly defined with real numbers and integers, it is possible to consistently define it, or similar operations, in other mathematical structures. Non-standard analysis: in the hyperreal numbers and isoreal numbers, division by 0 is still impossible, but division by non-zero infinitesimals is possible. Distribution theory: in distribution theory one can extend the function to a distribution on the whole space of real numbers. It does not, however, make sense to ask for a value of this distribution at z equals A0. A sophisticated answer refers to the singular support of the distribution. Linear algebra: in matrix algebra, one can define a pseudo-division, by setting a bar equals a plus, in which b plus represents the pseudo-inverse of b. It can be proven that if bar 1 exists, then b plus equals bar 1. If b equals 0, then b plus equals 0. See generalized inverse. Abstract algebra: any number system that forms a commutative ring for instance, the integers, the real numbers, and the complex number so can be extended to a wheel in which division by 0 is always possible. However, in such a case, division has a slightly different meaning. The concepts applied to standard arithmetic are similar to those in more general algebraic structures, such as rings and fields. In a field, every non-zero element is invertible under multiplication. As above, division poses problems only when attempting to divide by 0. This is likewise true in a skew field. However, in other rings, division by non-zero elements may also pose problems. For example, the ring Z/6Z of integers mod 6. The meaning of the expression should be the solution x of the equation. But in the ring Z/6Z, 2 is a zero divisor. This equation has two distinct solutions, x equals 1 and x equals 4, so the expression is undefined. In field theory, the expression is only shorthand for the formal expression ABA1, where bar 1 is the multiplicative inverse of b. Since the field axioms only guarantee the existence of such inverses for non-zero elements, this expression has no meaning when b is 0. Modern texts include the axiom 0 perm LA1 for fields so that the zero ring is excluded from being a field. In computer arithmetic, the IEEE floating point standard, supported by almost all modern floating point units, specifies that every floating point arithmetic operation, including division by 0, has a well-defined result. The standard supports signed 0, as well as infinity and nan. There are two zeros, +0 and a0, and this removes any ambiguity when dividing. In IEEE 750 for arithmetic, or AA plus 0 is positive infinity when A is positive, negative infinity when A is negative, and nan or equals AA plus or minus 0. The infinity signs change when dividing by a 0 instead. The justification for this definition is to preserve the sign of the result in case of arithmetic underflow. For example, in the double precision computation 12, where x equals a plus or minus 2 or 149, the computation x/2 underflows and produces a plus or minus 0 with sign matching x, and the result will be a plus or minus a with sign matching x. The sign will match that of the exact result a plus or minus 2150, but the magnitude of the exact result is too large to represent, so infinity is used to indicate overflow. Integer division by 0 is usually handled differently from floating point since there is no integer representation for the result. Some processors generate an exception when an attempt is made to divide an integer by 0, although others will simply continue and generate an incorrect result for the division. The result depends on how division is implemented, and can either be 0, or sometimes the largest possible integer. Because of the improper algebraic results of assigning any value to division by zero, many computer programming languages explicitly forbid the execution of the operation and may prematurely halt a program that attempts it, sometimes reporting a divide by zero error. In these cases, if some special behavior is desired for division by zero, the condition must be explicitly tested. Some programs will use behavior similar to the IEEE standard, using large positive and negative numbers to approximate infinities. In some programming languages, an attempt to divide by zero results in undefined behavior. The graphical programming language Scratch-2 used in many schools returns infinity or infinity depending on the sign of the dividend. In two's complement arithmetic, attempts to divide the smallest signed integer by are attended by similar problems, and are handled with the same range of solutions, from explicit error conditions to undefined behavior. Most calculators will either return an error or state that 1/0 is undefined, however some TI and HP graphing calculators will evaluate 2 to A. Microsoft Math and Mathematica return complex infinity for 1/0. Maple and Sage return an error message for 1/0, and infinity for 1/0.0. Historical accidents. On September 21, 1997, a division by zero error on board the USS Yorktown Remote Database Manager brought down all the machines on the network, causing the ship's propulsion system to fail. See also, asymptote, defined and undefined, indeterminate form, zero divisor, references, notes. Sources. Further reading.